Let's talk a little bit more about how to interpret P, that is the probability given by a significance test. This interpretation has already been presented to you. It conveys, given a true null, the probability of obtaining the study sample result, or an even more extreme result. Now, another interpretation of P is P conveys the probability of obtaining the study sample result, or an even more extreme result, due to chance alone. Now, both of these interpretations can be shortened. 2. P conveys, given a true null, the probability of obtaining the study sample result. That's shorthand for this result. And then we can also say P conveys the probability that the study sample result is due to chance alone. So these are just sort of shortcuts. The first definitions are more explicit. Hopefully you can see that the two just presented interpretations of P are conveying, in essence, the same thing. They are opposite sides, so to speak, of the same coin. So, suppose that the null is true. If indeed the null is true, then the difference between the value stated in the null and the result obtained in the sample is due only to chance. Now, the other side of the coin, if chance alone is the only cause of the difference between the study result and the condition stated in the null, it follows from that the null is indeed true. So, P conveys, given a true null, the probability of obtaining the study sample result, and equivalently it conveys the probability that the study sample result is due to chance alone. These interpretations mean one and the same thing. Now, here is a rough outline of the logic of a decision to reject the null. So, you're going to reject the null when you have a sufficiently low P. Given a true null, one reasons that my study sample result is an unlikely one. And from there you jump to the conclusion the null is likely false. And then therefore you reject the null. So in essence, the result is if the null is true, the result is a very unlikely one. Therefore, the null is likely false, and you reject it. And here are some other interpretations or other meanings that go along with the decision to reject the null. When the null is rejected, the study sample result is providing strong evidence that the null is false. When the null is rejected, the study sample result is highly inconsistent with the null. A decision to reject the null conveys to you that the null is likely false, and it conveys that the study sample result is unlikely given a true null, and similarly that the result is unlikely to be due to chance alone. So when you reject the null, you can be confident but not certain that the null is false. So here's the rough logic of a decision to fail to reject the null. Given a true null, my study result is not a highly unlikely one. It doesn't provide strong evidence that the null is false. Therefore, I will retain it. I will fail to reject it. Now, it's easy to misinterpret a decision to fail to reject the null, which is to say to accept it. So here are some mistaken interpretations of accepting of the null. So it is mistaken to conclude that accepting the null means that the null is true, or that the null is likely to be true, or that one can be confident that the null is true. These conclusions are too strong. more correct interpretations of a decision to fail to reject. So when you fail to reject essence, your study sample result is not providing strong evidence that the null is false. So in the absence of that strong evidence, you retain the null. So it's not that you're concluding that the null is likely true, but much more that you don't have evidence conveying that it's false, and so therefore you hang on to it. You don't reject it. And when you fail to reject the null, in essence that means that the study result is not a highly unlikely result given a true null. So if the null were true and you're failing to reject, that happens in a situation where you might well obtain your result given a true null. Your result is not an unlikely one given a true null. And similarly, when you fail to reject the null, chance alone is not a highly unlikely explanation. The idea is your result may well be due to chance alone. Chance alone could perfectly well and not rarely produces results as extreme as yours. So therefore you're going to retain the null. You're going to fail to reject it. And let's go to this one. So the study result is not highly inconsistent with the null. So it's not necessarily that your result is consistent with the null, but your result is not strongly inconsistent with it. It's not so different from the null that it suggests to you that the null is likely false. Analogies to a jury trial can help you get the feel for the meaning of a decision to fail to reject, which is to say retain the null. So in a criminal trial, a decision to find the defendant not guilty doesn't convey that it's likely that the defendant is not guilty. I mean, this conclusion is too strong. It only conveys that there is not evidence beyond a reasonable doubt that the defendant is guilty. So by the same token, a decision to retain the null doesn't convey that the null is likely true. It only conveys that there isn't strong data, which is to say strong evidence otherwise. And similarly, a decision to find a defendant guilty conveys that there is evidence beyond a reasonable doubt. Now, a decision to reject the null conveys that there is strong study evidence, that is data, that the null is false. So when you reject the null, you can be confident but not certain that it is false. Again, the decision to retain the null is simply one that says, I don't have strong evidence otherwise, therefore I'm going to hang on to it. When you retain the null, it's basically a situation where chance alone might plausibly, chance alone more than occasionally, produces results as extreme as your result. So, your result is not strongly inconsistent with the null. You could get your result very plausibly just by the luck of the draw. And so you hang on to the null. You fail to reject it. You don't reach the decision that it is true or it's likely that it's true, but rather that you don't have evidence otherwise. Let's think about the null hypothesis and scientific inquiry. So let's consider relationships between variables. I mean, much of social science research is the hunt for relationships between variables. So, in essence, the null is providing the simplest possible explanation for why two variables are associated in a random sample. The null asserts that the variables are unassociated in the population and that we are seeing the association in the sample simply due to chance, the luck of the draw. Now, science prefers the simplest possible explanation. So long as the null suffices, so long as sampling error alone, chance alone is a sufficient explanation, we're going to retain the null. Now the alternative offers a more complex explanation. It asserts that the relationship that we see in the sample is not due to chance alone. It asserts that the relationship more fundamentally occurs because the variables are indeed associated in the population. So the null is asserting the simpler explanation, the alternative, the more complex one. Science will accept the more complex one only when the simpler one doesn't suffice. So when we're accepting the alternative, I mean, we're in essence concluding that there is a real association in the population. And you know, when we accept the alternative, really saying that there's a non-chance explanation for the result. So we're seeing our study result, we're seeing our relationship due to the fact that the two variables really are associated in the population. So the association that we see in the sample isn't due just to chance. So when we reject the notion that chance alone is the cause of the relationship, then in essence we're saying there's a real difference, there's a real relationship. Sort of what we're trying to do here with our significance testing is we're really as humans, we're hoping to reject the notion that the relationship that we see is due simply to chance. And if it's not due to chance, then that's in a sense what we want. Then we've got a real relationship in the population, something really making a difference. But we don't want to conclude that there's a real relationship involved unless we can reject that simplest possible explanation, which is chance alone. Now let's introduce a couple more terms. The term statistical significance goes hand in hand with rejecting the null. Rejecting the null and statistical significance are one and the same. So when the null is rejected, we say that the result is statistically significant. And saying that the result is statistically significant says one and the same as saying that we are rejecting the null. And further, the absence of statistical significance, or saying the result is not statistically significant. This goes hand in hand with failing to reject, which is to say accepting or retaining the null. So when the null is retained, the result is not statistically significant. And to be redundant, when the result is not statistically significant, that's one and the same as retaining, which is to say accepting or failing to reject the null. And you know, it just as a general definition, you know, when we say that a result is statistically significant, what we're really saying is here is a result that is unlikely to be due to chance alone. Thinking back to our coin flip example, in our first coin flip example, we got 9 heads out of 10, and we concluded that given a true null of an unbiased coin, the probability of getting our result is simply due to the luck of the draw, and the sampling distribution showed us that luck of the draw, that probability was 0.02. So we rejected the null at the 0.05 level. That was a result that was unlikely to be due to chance alone. Chance alone produces that extreme of a result only 2 times in every 100 random samples. That's a statistically significant result, one that's unlikely to be due to chance alone. And to sum up what's been a big chapter, when chance alone, which is to say sampling error alone, is not a highly unlikely explanation for the study sample, result, we fail to reject, which is to say, retain the null, and we reject the alternative. Such a result is not statistically significant. And so when chance alone, which is to say sampling error alone, is an unlikely explanation for the study sample result, as for instance when we got our 9 heads, that's when we reject the null and accept the alternative. Such a result is statistically significant. And indeed, such a result is reflects presumably a real difference in the population. Such a result is not due to chance alone. Therefore, we conclude that there's some real difference at work in the population. It's a real relationship.